Die Sprachübertragung beginnt jetzt. Alle Teilnehmer befinden sich im Zuhörermodus.
Hello everybody and welcome to our webinar, the CATIA Creative Design Business Process Flow. My name is Honorata Frings and I will moderate this webinar today for you, while Gerard Alcini will give you an overview about all the great features and functions that CATIA has to offer. This webinar will be recorded and you can rewatch it on our CATIA Creative Design community as a webinar on demand on 3ds.com, and for all of you who registered to this webinar will get a direct link to the recording tomorrow. At the end of this webinar, you can ask questions and we will have some information on future webinars and events for you. If you have any questions in between, please raise a hand or write it into the question window. We will collect your questions and answer them afterwards. So now I am handing over to Gerard and I wish you a nice webinar.
Okay, thanks, Honorata. Well, good morning and afternoon to everyone, and happy Halloween. I hope nobody eats too much of their kids' candy tonight for those who go trick-or-treating. And with that, welcome to the CATIA Creative Design Business Process Flow webinar. My name is Gerard Alcini. I work in CATIA Technical Sales and the Center of Excellence located in Auburn Hills, Michigan. And so in today's presentation, you will see how CATIA Creative Design breaks down the silos between studio engineering and other downstream disciplines. We have some really nice material to show, and I will try to get through as much as possible into this 1 hour session. It was tough. I had to eliminate some things, but we do have a lot of good stuff to show. So let's get it started here. And we'll start by looking at some of the challenges. I think anyone working in product design long enough has witnessed a beautiful design morph into something else by the time it reaches production release. I certainly have. And there are plenty of reasons for this. But the obvious one is that design, engineering, and simulation are siloed. And these silos make it a time-consuming task to share data. And when data is finally ready to be shared downstream, it's already obsolete. So to get more specific with a couple examples, model stitching. This is an extremely non-value added studio activity required to close up gaps, overlaps, and continuity issues with surfaces before passing downstream for consumption. And it costs many man-hours to complete. It starts from the earliest stages in design all the way through to final surface release. Data translation. This is another non-value added, albeit less time consuming activity, but it just piles onto data obsolescence. Model preparation. So as themes mature, there will be periodic design validation reviews. The data preparation is yet another drag on the process that costs many hours to accomplish. Now add on simulation into the equation and then just step back and it's easy to recognize the bottlenecks. We're not here to suggest scrapping your design process, but we are here to show how you can supercharge and streamline existing processes with a truly collaborative solution. And this is made possible by using CATIA for design on the 3D Experience platform, where all stakeholders can access the same data. Engineering can change and update reference or envelope data that is used to govern the design, and modelers can provide solutions in real time as changes are being proposed in the reference or envelope data. And in regards to visualization, CATIA has a world-class solution that requires minimal preparation. So going into a design review is not time-consuming or stressing, and it uses current data. It's something very important to remember. The advantages of having an integrated solution are numerous, but the bottom line is that it can be streamlined, and the time frame from industrial design to tool development can shrink. This will also facilitate better decision making at all levels for a better end product. So how can the creative design business process flow on the 3D Experience platform help? Well, it improves communication of design concepts to Class A. For example, rapid conceptual modeling to hand off to Class A and engineering groups at an earlier stage. You'll see a lot of examples of that. Ideate multiple design options. So rapid modeling means more themes, and that drives better decisions. And improve design integrity. Communicate design intent while respecting engineering criteria. And that means making your design an intention rather than a result of late communication, obsolete or wrong data, or compressed timing. Improve visualization throughout the design process, such as physically based materials in real time, VR, or global illumination. Collaborative workflows, for example, co-designing simultaneously on multiple components, or validating design throughout the design process, eliminating oversights. And then human design. So why not include a realistic human mannequin within the design process for proportion, rendering, and design validation? Here's a look at the various aspects of a typical studio process. It often starts with 2D sketches, and they can be either hand sketches or digital, to 3D sketching with our natural sketch product in CATIA, to digital sculpting with subdivision modeling found in Imagine and Shape, and finally surface refinement in CATIA ISOM shape design. And as we move from the virtual world to the physical models, visualization is utilized for color and trim and in context design validation. So really the idea is, before spending big dollars on those full-scale physical prototypes, take advantage of iterating between live rendering and conceptual modeling early on. Then again, at the surface refinement stage.
Sorry to interrupt.
Yeah.
It seems someone can't hear anything. I don't know if anyone can hear us. Can someone raise a hand if he hears what I say? Okay, great, guys. Thank you. You're hearing me. So it's just one person. I will send a message. Okay, sorry to interrupt. Go ahead.
Oh, that's no problem. No problem. So I think we were talking about the live rendering. So you want to use that throughout the design process. So conceptual modeling, again at surface refinement, all the way through as the theme matures. And this is a high value, low cost alternative to making those physical prototypes. Not saying there's that to replace them, they're very important, but you can really have a high value alternative to having so many of those physical prototypes, and that's a big time and money saver. And then 3D printing small or large scale mock-ups using our 3D printing app, it's fast and it's an economical way to create physical parts throughout the process. Okay, so here we are showing a sequence of creative design workflow possibilities for design. We're showing cars here, but the workflow is consistent no matter the industry. So now let's take a look at some workflow examples at each phase. And we will start at ideation, where we can explore ideas from a community in SWIM, which means see what you mean. It's an acronym. This is where ideas can be shared and gauged for popularity. Communities can be set up through dashboards, and projects are created with team members, and a whole lot more. So what you see here is a laptop interface with access to all 3D experience services, like this dashboard created for a motorcycle project. Things like communities and team posts, trends, or any other widget you want to add to provide these really provide a great business value for designers. For example, here in the NetVibes feed reader, we can take a look on the web to find some inspiration, or create a community for collaborating with team members, or sharing ideas, our designs, our sketches. We can also go up here to the ideation tab, and we have an ideation funnel pipeline for creating posts. You can share ideas to the team and to mature the popular ones to a concept. So even before talking about 3D design and technologies, there are already very interesting dashboards, widgets, and services available, bringing value to the designer. And so here we are showing some more stored assets, and you can see images, sketches, rendering inside your community or the 3D space. In this example, we have a new fuel tank design for this motorcycle. As you can see, the team is working together in a community created for this project to share this information. So we'll start with an existing bike, and we're going to bring in a human mannequin. This is available in all creative design roles. And we're going to start by looking at the consumer experience. So adding this human, then we can globally move it. We can set the postures in the dialog box right there. So you can get pretty much 80% there, but just by one click. And so we're going to put this human in a driving position. And then at that point, we can independently position the hands. And there's even a feature to auto grab objects like those hand grips and collision detection, things like that. Human design mannequins have built-in inverse kinematics. So by default, you cannot overextend the joint rotation unless you override it. There is a setting there. And so redesigning our fuel tank using 3D natural sketch technology. So for example, during a review, a designer or maybe a chief designer can use this application to communicate a change by annotating their instructions. So in this case, we want to add a new windscreen, or maybe to take a look at the fuel tank. In this case, we're going to modify the shape. And these annotations, it's not something that's going to disappear when I share this model. It goes with it until someone actually erases the annotation. So it sticks around, and it's a great way to communicate. And that communication, it comes in a variety of forms. And so while in the same sketching application, Natural Sketch, we can easily sketch out our shapes with vector or raster-based 2D or 3D curves. So we're drawing these new design ideas for the fuel tank. We mirrored it, and then we actually lofted a surface through there and can manipulate the actual 3D curve and watch the tank surface update. Okay, so this is another interesting technology, and this offers a strong value in the design process. It's called Photo to Shape. This application was developed in collaboration with Procter & Gamble. It transforms real objects from photos into virtual 3D models. The goal is to quickly compare, rebuild, or redesign an existing model. This is a really strong need in the CPG industry, but the technology is so powerful and unique that it's sure to find its way into all industries, such as automotive, as shown here, and aerospace and defense, where we are working with Dassault Aviation. So some of the key functionalities and workflows for Photo to Shape are importing of photos, sketching elements on those photos, such as curves to define an edge, linking those elements to photos taken from different views and perspectives, and then watching CATIA automatically generate a model. Let's see how it works. If you are new to the command, there's a nice tutorial that walks through the sequences of how to map elements from 2 or more views together. So you advance to the next step, and then you just select key points, then make additional selections on that roof, and continue. And then in the next step, you define corresponding elements between those images and then compute the model. So on the left, you can see the actual merged viewports, and you have a 3D surface. Okay, so now we're going to move on to conceptual modeling and take a look at some 3D sketching concepts to express and communicate your creativity, and explore design alternatives and details by sketching on 3D. So we saw Natural Sketch used in the ideation phase, but like so many of our solutions, it has strengths throughout the design phase. And so if you can see here on the top left corner, you can do a 2D inspirational sketch. Then you can actually generate 3D curves from it on the bottom left. And then even as the themes mature, or if you have a scan, you can sketch directly on top of those objects with raster or vector-based curves. So you can see, kind of looks like a pencil drawing across the grill treatment. And then if you take a look at the left portion of that fender, you can see the points. That is a vector-based curve. So it'll do either of them. And so basically workflow would be to maybe sketch it out with a pencil trace. And then when you're happy with something, you would go ahead to the vector-based curve and draw that, and then you can manipulate those control points. So let's take an example here. So this is going to move pretty quickly. So it's sped up. We've drawn our 2D curves. We can switch views. We can actually turn those vector curves into 3D. There's a lot of different ways of doing it. And then sometime later, just minutes, or depending on how good you are, maybe a couple hours, you've got a nice theme. Now right here, what we're showing is an SVG file brought in from Illustrator. And you can actually put it into CATIA, and it will actually carry the layers over. But what's really intriguing about this is you can take that data and manipulate it. In this case, we're translating it. Now we're actually adding more points to some of those spokes. And then we'll do a circular pattern, and we can create quick surfaces for this to really get a good idea of our part. Now we're actually creating a surface in that headlamp area based on the 3D sketches. And you can see here a raster-based conceptual idea of the headlamp, and it's drawing right on the surface relative to your view. And that's really powerful. And then this is another example, creating a quick surface. And then because this is CATIA, we can use CATIA ISOM in this case to draw this fuel filler door or charging port, depending on what type of car it is, and move it around and actually manipulate it with the natural sketch curve. Okay, so sketching on support with the sketch tool. Let's give this a play here. You can do some smoothing of rough curves. So that's just changing the precision. And we can change the thickness of the curves, easily switch between the colors, and even put emissive materials on those curves on the sneaker. I think we got a repeat, so let's move on. Sketching on surface can be used to create subdivision surfaces as well. So you can see this designer with her Cintiq actually drawing a mesh on her surface. It's great. It's flexible for restyling. You know, in this case, we're starting with an existing shoe here. And it's a great workflow enabling quick design proposals or theme exploration, or in this case, with the shoe, drawing that mesh on the support to create a new shape. And this is a subdivision surface, and we'll get more into that momentarily. And since we are in CATIA, enriching our design with other aspects is seamless too. So here we can take advantage of knowledge templates or parametric features. In this example, we want to add stitch seams to our subdivision surface for an added level of detail. And by playing with parameters like thickness or number of stitches, you can very quickly explore the detailed design by combining these virtual clay modeling subdivision surfaces with the power of feature-based knowledge templates. And also keep in mind the visualization. This is a very key aspect to the 3D experience platform where we are designing in context with world-class real-time visualization. Okay, so you just saw some great sketch-based features in Natural Sketch and in Imagine and Shape. Now let's show how complementary they are, the sketching paradigm with subdivision surfacing. This combo is great for 3D sculpting of virtual clay models and really just general organic shape creation. It's an easy to learn, fun to use interface, and it's great for quick 3D design exploration. It really truly fosters creativity without those encumbrances of complex parametric geometry updates. And a few things to note: it's very fast during the discovery phase. All stakeholders can access the model for review. Engineering can change or update reference and envelope data that is used to govern the design, and modelers can provide solutions in real time. So this is a really cool example. So we're just sketching out this dash panel with raster-based curves, and then when we get pretty happy with these things, we can actually go over it with a vector-based curve and then manipulate those control points. Now this is a 2D plan view drawing at the moment, and we're just going through and getting the key aspects of that drawing, but watch how easy it is to turn those into 3D. And we can snap curves to other curves or do matching and cutting and things like that too, if somebody's wondering about that. Sometime later, we have a nice 3D drawing here. And what we're going to do is, again, we're going to put a surface through 4 boundary curves, and then we increase the resolution to get it more accurate. And so you can see there's a slider bar here that increases the fidelity of that surface, so it kind of suctions to those curves. And at some point, we will let the 3D take over, and we can manipulate just pushing and pulling these control points of the subdivision surface. And I said surface. This is not a polygon mesh. This is a surface that you can use for all kinds of applications. Now, this is a very tricky area on the side, and why not let CATIA figure out the tough areas? We'll just do it separately, and we merged it. We merged it with the rest of that dash panel, and so something like this can be done in hours. Okay, so let's show how IMA, that's Imagine and Shape. Some people refer to it as IMA, I think mostly in Europe. Let's see how it can greatly accelerate rework processes. So CATIA Imagine and Shape. So we have some really nice features to talk about here. The mesh and strip drawing tool creates geometry on multiple supports using the sketching paradigm you saw in Natural Sketch. You can use a Wacom tablet and a pen. It also works with a mouse. So in other words, strip modeling allows the user to draw subdivision patches on existing legacy surface data, scan data, or both. This is great for updating an existing subdivision model to capture changes being made on a physical clay property. And you can draw open structures on top of a support, draw and merge surfaces using the sketching paradigms. You saw that in the last video, and manipulate the structure in the same command. So let's take a look. So this model has both surface and scan data. And in Imagine and Shape, we can draw strips to create a new mesh using pen strokes. So without leaving the command, it's easy to reposition and modify the strips. And as you can see, they're also projected onto that surface. That surface is basically a projection base. And whenever we add or manipulate those strips, they get sucked right down onto that surface. It's just, and depending on, and it's view dependent. So whatever view you're in, that is the direction that it gets suctioned. And these extrusions detect the closest edge and snap to assist the user. So moving those vertices around is easy. And the edge treatments can also be made. So you can see that along the wheel lip. And this is real-time visualization. You can see the glow on that quarter panel. So it's very easy to get a good idea of what a change is going to look like. And this is rapid conceptual modeling. In this case, we're doing a rework to some existing Class A surface that's been released. Okay, so from inspiration to 3D reality. It's easy to do with the right tools. Okay, so let's explore how a 2D idea can transform into a 3D reality and how easily a modeler can explore design alternatives. So we're going to show, this is an example of our inspirational Ferrari there on the wall. And then we've already, I'm going to skip ahead, we've already got some natural sketch curves created. And so those yellow curves are the ideation that the designer first came up with. And the subdivision surface is built with those particular character lines. But at any point, at any given point, you can update that sub D surface and let it take over. But the whole idea here is to it's really available immediately to be shared with studio engineers to check feasibility requirements. Because if there is something that needs to change, the designer has ownership of it, and he can really take advantage of that engineering change and still own that design and make sure it's going to look good when it's released. So you can see here we're changing the front end. Now we're immersed into a nice environment, and we have a paint material applied. This is all real time. We're doing it back and forth, so you can see the change to the front end. Now we're going to go ahead and manipulate the roof. We're just trapping the vertices that we want. You can do other things besides pushing and pulling. You can do affinities, you can do translations, rotations, and you notice that there's different materials applied. Obviously, we have emissive materials applied to the headlamps. Here we're changing the front end. We're opening that up because we need to get more air through there. And so this video is only sped up, I think, 40%. This is basically real time you're seeing here. Everything you're seeing here geometry wise was created in Imagine and Shape, including those wheels, but not the human. Then we're going to go, speaking of the human, the mannequin, we're going to do first person view. And so that blue square is our target. Now we're going to go outside of the car and have a look. Now we can actually determine whether the eyes are moving. So you can see the target as we move it around. Now we can rotate the head. And this is a huge value because we can quickly identify early on in the design if we have maybe a blind spot. So huge value in this. And these are all real-time changes. Again, we're going to just go ahead and manipulate these fender flares. Try to give it a more sports car look. Of course, we'd have to widen the stance as well, but this is pretty much real time. It's an amazing modeling tool, and it's a must for any studio. Okay, let's move on, and maybe we can take a look at an interior idea as well. So we're going to do it with the seat design. So again, we talked about annotation, and this is how a designer can communicate with annotations created in Natural Sketch. For example, okay, we want to do a red leather here. Should we put some air vents? So you can see we actually sketched out the design of the air vents and some inspiration with the headrest. Maybe ask if we can do a wood material here. We can draw right on the surface. That's a raster-based curve. And now we're going to go ahead and model the seat cushion. So this time we're starting with the closed volume. It's up to you. You can have an open skin or closed volume. Starts out very simple, but we can change our perspective of our view. We can add edge, what some might refer to as edge loops. In CATIA, we call them section cuts. And so we can increase the resolution of that surface. And now we're just manipulating this cushion. With or without materials applied, you can see the perforated material on this seat cushion. And we can do other things like symmetries, so that we're only doing half of this seat. The other side comes for free because we've designated a mirror plane. So you can see as we pull on one side, the other side reacts. And this is very interesting, where we're going to generate a cut surface. Again, Imagine and Shape. Can be anything though, it can be made in GSD or ISOM or whatever, and split. We're going to split that original Imagine and Shape seat cushion and fillet this thing. And now we're going to play around with the splitting surface, and you can see this is almost real time. We sped it up. I sped it up 200% because it's a long video. And then we've got a new material here, this camouflage, compliments of Charisse Caldwell. She loves this material, and this is her design, this is her work. But she puts a stitch in here, and so this is real geometry. Again, we talked about it a little bit with that shoe, and those stitches go along with it. Now we're taking a look at the materials, which we'll talk a lot more about soon. This is a a substance material. The pattern is not from an image, but it's generated by an algorithm. So, and we also take note of the UV mapping. It wraps around the seat. You don't see a new pattern emerge with surface seam. And now this is the real-time render ray tracing mode. If you saw your screen get a little fuzzy, that's what it was. The longer you let it go, the more the better and higher quality that the picture becomes, because it's calculating refractions and the light bounces and emitting photons. So the longer you let it go, it's going to be a better picture. Okay, so now let's put together some of the great things you saw, showing how 3D Experience breaks down the silos of communication. This first example shows how a surface designer and a structural engineer collaborate with a co-review session showing a new hood that the studio is revising. So you can see that these guys are both sitting in their seats, but they're doing a co-review. And the guy on the left, the surface designer, is proposing a new hood. And so the engineer on the right is overlaying the surface to his structural hood component. And what he's going to do right now, the structure is referencing the initial hood, and we've added this packaging requirement because there's a larger engine option. So we need to put a power dome in this hood. And what you're going to see is the structure update as we replace the initial hood with the new one. And the engineer is going to update his part, and I don't know if you can see it in the structure, but you can see how it accommodated using the Change Studio Surface proposal. And so this can change a lot. This can really speed up the workflow, because in this case, they were both work in progress, and we avoided making an ECO, an engineering change order. So this is really a big deal on the platform, where you can do these co-design and co-reviews, and it's a great way to collaborate between studio design and engineering. Okay, so CATIA does provide a unified modeling environment, as you've been seeing. This enables designers to mix several modeling mathematics together to improve the digital workflow and enriching the design quality and creativity. So we've created that wheel lip flange in CATIA ISOM. And what we're doing is we're actually matching the Imagine and Shape subdivision surface to it. So we are actually gluing it together, the subdivision surface to an ISOM surface, and then we can manipulate the designs from there. Okay, so that was conceptual modeling. We're going to move on to packaging and feasibility. So in CATIA, there are no limits for packaging studies. I mean, there's too many to cover today. So what we're going to do is focus on a co-design scenario where a modeler and an engineer have a part review in order to discuss a new packaging requirement. And this is all without leaving their seats. So their data, as you saw earlier, so their data can be shared in a session without exporting, and this really greatly accelerates revisions. So let's take a look. So this was made in last year's release, still obviously relevant today. So on the left side, you have a packaging engineer who has been charged to come up with a larger volume for this center console bin cover. And so what he's doing is he's contacting the surface designer, and they're doing a co-design session, a co-review, and he's actually overlaying the part on the surface designer's session and gave him the data in that session, transferred it. And so now the surface designer is just opening up that part in a new window, and we're going into CATIA ISOM. And this is an explicit surface here that we're just manipulating control points, but you see all the other surfaces are updating because those were created parametrically, just basically with their history. It was very simple. It's very simple to do with those blends and fillets, and it's updated. So now there's an instant messaging session, communication between the two. The surface designer is proposing a new design, and he sent him the model. And now the engineer on the left side is taking a look at it, evaluating it, making sure that the volume requirement for the A side is clear. And on the right side, the materials have already been applied, and it's just a matter of getting the studio to buy off on that change. Okay, so now we have another example of collaboration, this time without co-design. Here we are showing an industrial designer using a Cintiq, and he's going to sketch out, oops, let's see if we can get this to play. There we go. He's going to sketch out a change in order to accommodate feedback from engineering. And so the red geometry represents an area where the hood surface needs to clear. And so he drew a couple sections in the plan view, and then one in the front view, and he's got a quick imagine and shape surface where we can get a conceptualize the idea. And then a little further down the road, we can actually move into the surface refinement phase once it's all bought off. And here again in CATIA ISOM, we can actually keep associativity by splitting those surfaces, and now we're just basically filling in those holes with a command called patch from curves. This is a really nice command, and you can set your continuity up to G3 to do these blends, and we just checked the highlights. And now what we're going to do is create, put a gap. Again, in CATIA ISOM, this is a gap tool that will take inputs, and we'll talk about that in a second. And then we can do a feature modeling of that design, and even the gap will change. Okay, so advanced design and packaging rely on human factors. So for this, there is the human for ergonomics application. That is a different application with different roles for a different purpose than with human design on the left. You know, which we'll talk about this for a couple minutes. There are three major areas where your design can be enriched with a human context. You already saw a couple examples of it with the motorcycle. Really, the three areas are to enable designers to create better designs by using human references, or use human posture in your design to validate or to create your design. And number three is to understand the proportions and volume by putting a human reference in the design. So here's an example of using a human as a reference to model around for the seat concept. So we added this human, we're in a sitting position. And now we're gonna go into imagine shape and just kind of build the seat around the human. So we start with this watertight closed surface. After some simple orientation and positioning, we can immediately begin to shape it by pushing and pulling on the mesh. Again, operations like translate, rotate, affinity, they're all available for this mesh interaction. We can create additional formations of the subdivision to give the surface more resolution. We can change the edge treatments, draw the seat, and kind of make the thing go around the side. And for the support, it's just as the name implies, imagine and shape. It's really easy to model. You know, the way we see things in our minds. It's a deliberately clean interface. It eliminates the distraction from the creative white space, and it's really just a simple workflow. Even though it looks like it's kind of a little messed up on the center from the designer, it's resolved because there's a symmetry that actually remedies that. And then soon enough, you've got this concept. It's a very quick modeling solution. Okay, so on to surface refinement. CATIA ISOM, it's world-class. Obviously, ISOM Surf is world-class, and CATIA ISOM has ISOM Surf algorithms inside of CATIA ISOM. But the nice thing about ISOM inside of CATIA is you have the associativity factor, which gives it another level of power at the user. So this surface is it's used to generate Class A production, obviously, but it's more than that. It's a flexible modeling tool. It lets the modeler decide whether to work explicitly, parametrically, or maybe a hybrid mode where explicitly created geometry drives parametric changes. You saw a little bit of that with that armrest bin. This is a very mature and well-appointed application, and we can't do justice to this application today because we just don't have time, but we're going to have a couple examples. This is just a quick one. It's one of 100 ways of surfacing this hood scan. So what we did is we created a simple patch. The video sped up a bit, but not much. And what we've done was we projected it onto the surface. Now we're using control points and some diffusion laws with an exaggerated view just to make sure that we follow the design intent closely. We're adding a matching constraint across center line and imposing G2 continuity, so we're curvature continuous there. We can increase the resolution of the surface. Now we're going to accelerate it towards the outboard. Do the same thing for this outside portion. We project the surface on, go into our control point manipulation, add some diffusion laws, fit the scan as good as we can with the exaggerated view. Now we create a blend in between those two guys. Put some section cuts. Now, of course, that blend is going to update as we change the edges of this explicitly created patch. The blend in between is associatives. And what we can do also is we can do what's called a feature modeling. And we've added some crown to it. It's really hard to see those sections in this. I'm sorry about that. But as we manipulate the surface of the main hood surface, the blend and that blend reacts. And now finally we're to the filleting stage. A lot of very powerful fillet tools in CATIA ISOM, which we don't have time to cover today, but there are plenty of ISOM webinars that you can get more information on this. And finally, we're just putting some highlight analysis, zebra stripes on the hood, ensuring that we don't have any issues across center line. And that's that one. This is another example. We showed the create gap a little bit when we were showing a concept, and let's just kind of show it in a little bit more detail. So we've got this gas trap area, and that green curve is our input. We have two inputs, the surface and a curve. And in this case, this is a really neat command where we can actually define the radiuses of both panels. So we have the door of the filler cap itself and then quarter panel. And we can input the gap, the continuity of the fillets, and very important, the direction of that flange in this case, which we had normal to surface. Now we're going to pick the direction. We're going to pick that z-axis of that axis system. We can easily flip the surface by just clicking on one of those arrows. And the other nice thing about it, if you take a look at this curve, that gap is defined equally beyond relative to the curve, but we can switch it to side 1 or side 2. So if you're given a cut line and the designer does not know which side is going, that gap will be measured against, you always have the option to flip it to either the center, side 1 or side 2. And now we're just going to go ahead and put a dynamic distance analysis. Just double check and make sure that this gap is in fact the 4 millimeter gap as specified in the command. And as you can see, the minimum and max are they're dead nuts. It's 4 millimeters. Okay. So on to product review. This is general terminology used for quite a broad topic. You see it showing here at the end of the creative design workflow cycle, but most reviews can take place during the entire design cycle with a final review at the end. And a key component of doing product reviews is good visualization. This segment will focus on how designers, engineers, and managers can leverage the 3D experience platform to perform not just daily reviews from a WinTop dashboard or just everyday design and engineering use, but also final product reviews. But first, let's take a look at a webtop solution. And there is no CATIA required for what you're about to see here. So 3D Experience has an app called 3D Play, which is a lightweight visual navigation tool that works from any WinTop or an iPad. This is a great way to keep connected with your team's progress. And it's ideal for team members who may be away from the office or managers who don't have CATIA. It's easy to drag and drop 3D content from a swim community. And so here we have a collaborative space I have access to. And let's just take a closer look. So here I'm going to do a search, and I'm going to drag a light assembly from my collaborative space into my CATIA 3D Play widget, and then from maybe a related project. So this makes my dashboard very dynamic for reviews. And these are 3D Play widgets you can spin around. Again, this is not CATIA, no CATIA required here. And it's great for managers. Here's a nice way to browse content, again, without CATIA. And with this web-based browser, I can easily slide my way through 3D data from a project for review with the manager. And this can include 3D parts from my team. It can include ray traced images, or even animations, videos which are stored in the database. Okay, so now let's talk about high-end visualization in CATIA. In the context of design, the purpose is not to see pretty pictures, okay, but it's to get a very good idea of what something will look like in a physical environment. Our vision is to change the traditional visualization process of our customers. So on the left side, today, customers are using sophisticated shaping apps. There's plenty of them out there. But when it comes to visualization, they have to go through a conversion process to prepare the data before a review, whether it's on a Powerwall or in VR. But whenever there's a design change, you have to repeat that process over and over, and that's really time consuming, and it bears a great cost. But with integrated solutions and workflow, our strategy and vision is to have a shaping and visualization coexist, so you can go from shaping to visualization and vice versa at any given time in one tool. So you may call earlier some of the quick conceptual modeling with physically based materials applied. That's out of the box function in all of our design roles. Content is very important, and it's to enable visualization for both the viz expert and casual user. So you can see these images here. It's a short selection of examples that are purely technical elements. So making high quality visualization easily allows everyone to quickly visualize the technical aspects of their designs. And here's a nice example. Shut that music down. I don't know if you heard it or not, but this is a great example of taking a look at the spike engine. So it's quick and easy to add materials. So you can see on the right, we've done a material search, and we can just drag and drop just a couple clicks, and we can even create an environment or just pick an environment. And this is the cool part, is we can actually run a simulation. This is world-class visualization in real time, running a simulation, going on a turntable, spinning it around. We can even do a section cut while in a review, do some measurements, add transparency to our parts, and even run the simulation. We can do these things together. And now you may see this really nice environment, and we'll talk about some of the procedural materials, including the brick that this bike is sitting on. Now we're changing some of the aspects in real time, our depth of field, going into our appearance properties of the material. We can change the colors. All in real time, depth of field. You can see the reflections of the environments on the geometry. We could run simulation and change variants, change colors, go through into our substance connection, which we'll talk about momentarily. Add some really cool materials like this carbon fiber fender, add some glossiness to it, change the fiber shape, with just a very simple interface with these slider bars. This is all in real time. Step back and take a look and quickly go do some design exploration of our motorcycle. So being on a single platform where modeling and visualization can be performed without having to export and clean up data, it makes creating shots like this easy, and it offers a huge value to designers. So again, we're talking about realistic studio reviews where you can place your design on a turntable or even create an animation. This car even has decals placed on it, which is another easy task available in live rendering. And achieving this great visual quality can only be reached with great materials, which is why we now fully support algorithmic substance materials. Algorithmic is one of those market leaders in procedure materials, and these are materials based on mathematical algorithms. So let's take a look at these material properties. The substance connection option is fully integrated in CATIA live rendering. There is access to all the channels exposed by the substance archive, so you can play with all the parameters, seeing the full power of those substance materials. And this is not only for auto or aircraft interiors, but for architectural use such as bricks, walls, floors. You saw that you saw the paver bricks with the bike. That was algorithmic material. Basically, any procedural material can be exposed in CATIA live rendering. So here you can achieve very realistic results using these materials. So here with the steering wheel, the leather, we can also change the output size of the image, luminosity, contrast. Very easy interface. And you can play around and come up with all kinds of different color and trim options. So to enjoy high quality visualization, you need those proper materials. And by the way, what you see here is a material in the content collection inside of CATIA. And not just leather, we have 119 materials in 9 categories, as you can see here, such as fabrics, plastic, stone, paint, wood, glass, leather, metals, and nature. And it's not just 119 materials. We have a lot of procedural materials. So for one material type, if we change just one slider in the procedural input of the mathematic formula, you can get a completely different appearance with an infinite number of combinations just out of a single material. So let's take a look at some of them in the content collection. First of all, we've integrated leathers and fabrics for our customers and consumers' lifestyles. So you can see how good the quality and high-end visualization of proper materials makes this possible in CATIA. These are materials coming from the content collection. With the fabrics, we put a lot of effort in different structures across industries, so you have a lot of variety of choices here. Again, this is just by going into the substance connection parameters and changing the material out, obviously on the same surface, so you can get a lot of different looks. Again, this is the content collection. Car paints are not a category, but and they can be a big challenge for a customer because it's really difficult to parameterize the render properly and hard to parameterize the material itself. So there are a lot of very good car paints with proper flakes inside the content collection. Metals, we have a lot of customers who build or design products based on metals, so we put a strong effort on importing very realistic metals that can be used in CATIA. And with plastics, you can see carbon fiber as one form, but there are other plastics for high-tech and CPG customers too, as they also see the importance of good visualization with proper content, to validate their designs. And glass, which is usually complicated to configure and parameterize. So we have already pre-configured different types inside the content collection for a variety of uses. And woods and natural materials, usually they are so rich that it's too complicated to make, especially if you want to tile them. We configure them in the content collection and they tile very nicely. I mean, look at that walnut, it's beautiful. Actually, that looks like the walnut there. Okay, and nature, to put the product into the right context. You can see we have natural materials inside the content collection. Take a good look at this. This is not a photo or a scan. This is full mathematically generated procedural materials. And to show you, we go into CATIA live rendering, and just by switching one selection, you change the structure. Keep in mind, it's always the same stone, but by changing another slider, you can change the aspects by changing, for example, the edge damage, the cracks, color, or even water level and darkness. So you really can get a completely different look in the material through a very simple user interface. This is just amazing stuff. I'm still blown away by it. And it's fun. So I hope you get a chance to explore this type of thing. And if you don't have CATIA, well, you need to send your manager to the recording of this webinar, or we'll be glad to talk to them personally. Okay, let's talk about ray tracing capabilities in CATIA that create realistic lighting, shadows, and reflections. This slide shows the consistencies achieved with all of our render models. Starting on the left side is real-time rendering, in the middle is iRay, and to the right is Stellar. Ray tracing, reflection, self-shadows, and color bleeding are all available in iRay and in Stellar, the two on the right. Stellar render engine it purposely utilizes the CPU for ray trace rendering, as it is really staged for future CPU cluster rendering. So you do have the option in CATIA to go with iRay, which is GPU, and Stellar, which is CPU. And it's just a simple pull down preference. So you have your choice of render engines. Now let's take a look at some ray trace renderings. Here's a nice interior shot. You can see the self-reflections. It gives you a much richer and realistic look. So you see, if you take a look at the gear shift, you can see the other geometry reflecting on it. And this is ray tracing, where it's calculating the refraction, real light bounces all over. So, and interior shots are more difficult to do than exterior, but you have all that global illumination, and you can add artificial lighting as well to get the look that you want. And you can see that there's a depth of field here. You can change your exposure and things like that. Perspective. Just another shot, nice interior shot of the door. So ray tracing can make stunning pictures like these, thanks to physically based materials and high definition environments. Take a look at the flakes in the wheel fender. But rendering in context of design is really important to show what a product looks like with different lighting conditions or environments. In this example, we see too much reflection of the dash panel on the windshield, and that's a distraction to the driver. So it's very important in the context of design and engineering to get an accurate idea of what your product is going to look like, not just for glamour shots. And in this case, with the bike, we can sequence through different knowledge patterns applied to this headlamp. And again, the value of having true ray traced images can save time, money, and headaches. Here, the bleed through of this chimsel can be seen reflecting off the sheet metal right here. Okay, so far you saw some very nice modeling solutions and world-class visualization. But what about a sophisticated tool for decision makers that can explore different design alternatives and color and trim variants? For this need, we have Product Experience Presenter, a simple visual interface made for authoring and presentations, specifically made to compare product variants and design alternatives. It's all about making design decisions visually, and it works on a desktop, touchscreen, Powerwall, and virtual reality. Okay, so let's take a look here. So you can see our motorcycle here, and to the left and right we have different cameras. We have different parts that we can exchange. So we can actually change. We can have multiple different shapes for a seam, different color and trim options, different parts and configurations. We can have different cameras, specific review cameras for an actual design review, and we can swap out components, as you can see here. So the headlamp, we're just changing that out. So this is an authoring tool and a review tool. So there's the authoring and review modes. You can see here we're changing out different fender configurations, swapping out the material with the carbon fiber, going through our different rim materials. It's an amazing tool. It's new in this in our current release, and something that's really adding a huge value and need. And you can even change positions here with the steering angle and the bike stand. So these are configurations that in the authoring mode you set these up, and then in review it's just a matter of clicking on the thumbnail. And now we're adding the human element just to give our design a context. It's really valuable to add that human aspect for these types of things, to get proportions, for visualization purpose, so on and so forth. So, okay. And now let's take a look at the immersive visual experience. It's a solution for one-to-one scale product visualization. This is the ID card we're looking at here. So there's just looking at some of these highlights. We support the HTC Vive. You can use multiple GPUs. Can be served on a large cave system. And there are basic navigation capabilities and so on and so forth. We're going to go ahead and cover this in a few slides. So this row is the entry point for all VR technology and on any 3D app that you may be using. So we're running low on time, so I got to get moving here. We're running out of time actually. So this is This is a scene with our bike, and we can actually change the materials out. You can see we went on that fender pipe. We added like a kind of a rusty material to it, and now we're going to go ahead and change out some of the material vectors. These, in this case, with the dash on our bike. And now we're going to go through and we're going to go into our VR. So we can set up a few parameters in the navigation here. Hit OK, and now we're in VR. And so now we can really get down and get a good one-to-one look at our design. Okay, and now we can go back into desktop mode, change some of the materials around. In this case, we're adding transparency to our engine. Go back into nav mode, and we can even run a simulation while we're in navigation mode. I'm sorry, while we're in VR. So again, now we're in VR. We set it up on our desktop. We're running that simulation with our transparency materials applied. Okay, so I'm gonna move along. So here we're showing newer functionality that allows interaction in VR. Now we have access to hide and show parts. And we're able to measure aspects of our design as well. So we can, just by pointing and clicking, we can hide or show parts, and it's also easy to reset. There's a reset button if we want to bring them all back to the initial stage before we went into this mode. We can switch our navigation mode. And do some measurements. So we're picking reference point. So now we're going to measure the in between the handlebars. And we can do an exploded view. I like this one. First we'll hide whatever we don't want to see. Oh, I'm sorry, this is a section cut. Then we'll do an exploded view. So we could cut a section and have full access to control where that section is while in VR mode. So we can drag it up or down and set which plane we want to cut it in. Again, we're hiding parts here. With the section on, so you can couple a lot of these things together, this functionality. And it's not just one thing at a time. We can do section cuts, hide show parts, do measurements. We could do an exploded view, which I think is coming up here. And these are all controlled by gesture. So you can see how we pull our handles apart, and we can actually explode this, hide or show components, and get down and really kind of do a really neat exploration. Okay, so now let's show some immersive collaboration. So let's just get right into it. So we have a designer here working, let's play this, on a sailboat project with a colleague in another country. And so through instant messaging, he asks him to join an immersive visualization co-review. And so now they're communicating back and forth. And so you can see this is from each desktop. They're both meeting in this 3D space, viewing the yacht and with independent control of their positions. And now they're going to put their headgear on. And they're both going to join the session, a collaboration session. And you can see it's easy to see others in the session and get their name from the system just by pointing at them. Now it's just a matter of checking out the design by doing product fly-arounds, making inspections, even changing perspective. There's immersive tools, include teleporting, ghosting mode, so another person doesn't get in your way as you get closer to them. And you can check out things that you would never normally be able to see, you know, with a physical prototype, you know, at the top of that mast. So, and then sit together with your team, you know, inside the design, and take a walk as you would with the real mock-up. And since this is CATIA, it's possible to review your design no matter what stage of the process and identify potential issues early on. And at any time, anyone can leave the session. So on the left, you can see that person's left the session. The person on the right is still in the session, and that bench right there, the person on the left is going to swap out the geometry, while the person in VR sees these changes dynamically. And then the second person can return the VR session, and you can continue your review. Okay. There are some other nice tools for scrutinizing your products, like this turntable, or actually picking up the part. You can never do this in real life, so take advantage of feeling really strong here and doing some pretty cool exploration and inspection by just dragging and dropping grabbing a hold of your part. And it's there's an easy reset button on here too. Okay, where are we? We're running out of time here. So today we showed the challenges that most design and engineering studios currently experience and how the 3D experience platform can address them. You saw how our solution covers the creative design workflow from ideation through the design validation phase. We also showed 3D sketching in various forms from subdivision surfacing to Class A modeling, and throughout the design stages, how human design mannequins can be used for many purposes. And finally, how our world-class CATIA visualization is there for design and engineering daily tasks to VR immersive collaboration and all the way through final product reviews. So I guess it's time for questions. Honorata, if you want to open it up. I know I'm sorry we ran 10 minutes late. I thought I had this time better.
No problem.
So
if I have
leave
one
it to you,
question
Honorata.
here. Yeah, I have one question received already. So first of all, thank you for the presentation, Gerard. And Jose would like to know, what is the minimal
I
configuration
hope
for
that I'm still
PCs?
broadcasting because
You are.
I can't do anything right now. So let's see
Can you
here.
hear me?
Yes, I can.
Okay. So the question is, what is the minimal configuration for PCs to run this software?
The minimum for PCs to run the software. Well, you know, hardware is pretty darn good these days. If you want if you need a good visualization tool, a good visualization graphics card. I run mine on a laptop. It's a Lenovo W541, and it's got an M2000 graphics card. But if you can get a workstation with any P cards, a P6000 would be wonderful. But if you go to 3ds.com, we do have support that will give you certified configurations for the hardware. So the hardware is coming way down. You know, again, I run CATIA on a laptop, and some of those videos were mine. So, it doesn't take they've got some good horsepower these days.
Okay, thank you. Do we have any more questions? If you cannot think of a question, but later you maybe have one, please don't hesitate to send me an email. I will forward it to Gerard and we will answer all of your questions later. And again, this webinar was recorded and you will receive an email tomorrow with the link to the record. So thank you to everyone. Thank you for your patience and time. And I see you next time. Goodbye.
Bye now.